Elasticity of demand. Retailers and manufacturers often need to know how a small change in price will affect the demand for a product. If a small increase in price produces no change in demand, a price increase will increase the revenue, so it will be advised to increase the revenue by increasing the price a little bit. If a small increase in price creates a large drop in demand, then we say that the increase will probably decrease the revenue, will increase. If you increase the price, then the revenue will decrease because the demand is going to drop. To measure the sensitivity of demand to increase in price, we use elasticity of demand. Elasticity of demand, we're going to call it E of X, is given as a function of price X by E of X is equal to negative X times the derivative of demand function, D of X, divided by the demand function, D of X. So again, negative X, which is the price, times the derivative of the demand function, D of X, or sometimes we call it Q, over the demand function, D of X or Q. Sometimes we call that Q as well. So I'm going to write that down. D of X sometimes is called Q. So if total revenue is increasing at those X values for which the elasticity of demand function is less than 1, then we call the demand inelastic, and that means an increase in price will bring an increase in revenue. So it is advised to increase the price in order to increase the revenue in that case. If demand is inelastic, then the revenue is increasing. If the total revenue is decreasing at those X values for which the elasticity of demand function is greater than 1, the demand is elastic, and that means an increase in price will bring a decrease in revenue. And in this case, we advise not to increase the price. If the demand is elastic, then the revenue is decreasing. Total revenue is maximized at the value for X in which E of X is equal to 1, or the elasticity of demand is equal to 1. We call the demand unit elastic in this case. And the demand, if the demand has unit elasticity, then the revenue is at a maximum. So when we have E of X is equal to 1, that means we can get a maximum revenue. In that case, we're not going to change the price. We're going to keep it as it is to maximize the profit. So let's look at some examples. Let's look at the first example. A company found the demand for its product to be Q is equal to D of X is equal to 400 minus X. We want to find the elasticity function. We want to find the elasticity at a price X is equal to 124. We want to determine if the demand is elastic or inelastic and then interpret the results. Or what should we do? Should we increase the price, keep the price as it is, or decrease the price? And finally, we want to find the price or value for which revenue is maximized. So let's start with the beginning. To find the elasticity function, we're going to use the previous formula, this formula right here. So we're going to say in this case that since the elasticity of demand function is equal to negative X times the derivative of the demand function divided by the demand function, so that's what we're going to do. We're going to say E of X is equal to negative X times the derivative of the demand function, this function right here. The derivative in this case is equal to 0 minus 1, so it is equal to negative 1. So this is times negative 1 divided by 400 minus X, which is D of X, or the demand function, or Q. The next question is asking to find the elasticity at a price of X is equal to 124. So let's find the elasticity at 124. All we need to do is to put 124 into this function, plug it in, So we will have negative. Instead of each x, we're going to replace it with 124. So sorry here, I didn't simplify this expression. This expression will get me negative times negative is positive x divided by 400 minus x. Here I will have 124 divided by 400 minus 124. And to compute that, you're going to find 0.449. In this case, you notice that this value is less than 1. If we go to the previous slide, it says that if E of x is less than 1, then the demand is inelastic. In that case, an increase in price will bring an increase in revenue. So that is how you're going to interpret that. So if you increase the price, the revenue is going to increase as well. So in this case, the advice will be to increase the price. All right, to find the maximum price that we can charge to maximize the profit, we're going to find the price or value for which the revenue is maximized. So how do we find that? We know that from the previous slide, we know that the maximum revenue happens when we have unit elasticity. That means the demand, the elasticity of demand is equal to 1. So we're going to set the elasticity of demand equals to 1 and solve for x to determine the price, because x represents the price in this case. So we're going to say E of x is equal to 1, which is equal to x over 400 minus x, and then we're going to solve this equation right here. To solve that, we have to cross multiply. So we have 1 here in the denominator times x is equal to 400 minus x times 1 is 400 minus x. And now we want to solve for x, so we're going to gather the x's together. We're going to add x to both sides. So that will give us 2x is equal to 400. I divide by 2, and eventually I'll get x is equal to $200. So to maximize the profit, I'm going to set the price to be $200 in this case. Here is another example. We are given the demand function d of p is equal to 200 over p. In this case, you can replace p with x if that is making it a little bit easier for you. P here is just a variable. We want to find the elasticity of demand at a price of $71 and then answer the rest of the questions. So to find the elasticity of demand function, it is equal to negative x, or in this case it is negative p, times the derivative of the demand function divided by the demand function. Notice how I replaced all of the x's with p because that is the variable that I have here. Now I'm going to find the elasticity of demand. Notice how I have p in the denominator, so the derivative here is going to be a little bit tricky, so you have to think about it a little bit. I'll do it here. I have d of p is equal to 200 over p. I am going to bring the p up with a negative exponent and then find the derivative that way. D of p is equal to, I'll bring the negative 1 down, so that will give me negative 200. P of negative 1 minus 1 is negative 2. Now I will bring this is the derivative. Now I will bring the negative exponent down with a positive exponent, so this will be negative 200 over p squared. So d prime of p is equal to negative 200 over p squared. Now I'm going to replace everything here. So I will have the elasticity of demand is equal to, this is p, negative p times negative 200 over p squared. Everything is over 200 over p. Now the first thing I can do is to cancel one of these p's. And this p, negative times negative is positive. So I'm going to have positive 200 over p over 200 over p. Now, this amount is the same as that amount, and that will give me 1. So the elasticity of demand is equal to 1, and that means the elasticity at $71 is still equal to 1. So the answer here is 1. At this price, we should say that the demand is unit elastic. In this case, it is unit elastic. The revenue is at its maximum. If you go to this slide, if E of X is equal to 1, then we have a maximum revenue, and we're not going to change the price in this case because a change in price could decrease the demand, and in this case, decrease the revenue as well.